So this is the first of a few short talks. There'll be a break between them. And this is Robots on Mars. We'll be looking at Mars and Martians, thinking about landers and in particular rovers. What have they found and where are they heading? At least what is next in store for Mars? So we, as in Earthlings, have had a fascination with Mars and indeed Martians for quite a while. Some of us will remember War of the Worlds, either the book or the film or maybe the musical. For the youngsters, maybe when you say Martian, you don't think of War of the Worlds, maybe you think more of Matt Damon. Fair enough. But it's worth just taking a second and reminding ourselves how amazing it is that there are robots on Mars. We have built machines, put them on top of a rocket, sent them to Mars, and they are now exploring another world. The fact that we are able to do that is incredible. The technology required, of course, is the result of many decades' effort. But the fact that we can put a robot on Mars and take images like this, explore the landscape, find out what it's made of, dig into its history, try and understand one of our sister worlds, one of the closest planets to us in the solar system. It looks like there's no life. It looks like there's no water. But that's misleading. There are dried up riverbeds. There are gullies. There are signs that water has flowed on Mars. So we think there is water on Mars, perhaps subsurface. So we don't see life when we ask our rovers to send us pictures, but maybe it's there. We need more rovers. We need more digging. We need more exploration. There have been quite a few landers and rovers sent to Mars. Here's just a list of the NASA ones. I'm not going to talk about all of the rovers that have been to Mars. Back in 1976 was a lander called Viking. In the 90s, there were other missions. In the early noughties, there was small rovers called Spirit and Opportunity, sometimes called Oppie to its friends. Another lander in 2008, Curiosity in 2012, and finally in 2020, only a few years ago, was Perseverance, otherwise known as Percy. So I'm not going to have time to talk through all of these. I'm just going to pick out the ones in red and say a little bit about them. This is the one I remember from the 1970s. This is a scale model of Viking with Carl Sagan providing a sense of scale. This is the first color images we got back from the surface of Mars. We assumed it would be red, but it's great to actually see color images from another planet. And when I first saw those back in the mid-70s, I thought, that is amazing that we can do that. Actually getting to Mars is not so difficult compared to getting to other parts of the solar system, simply because the Mars orbit, if you come and have a look at the orrery on the front bench later, the Mars orbit is not far outside the Earth orbit, so it doesn't take a huge rocket to get there. A relatively small rocket will get a small payload, like a rover, only weighing a ton or two, to Mars. A lot less of a rocket compared to, for instance, the mighty Saturn V that was required to get only to the Moon, which of course is a lot closer than Mars, but the Saturn V was lifting many, many, many tons of Apollo spacecraft. The Saturn V could lift about 100 tons, but to get to Mars, all we want to do is to send 1 or 2 tons of rover or lander. Therefore, we don't need anything like the size of the Saturn V rocket. Here's an indication of how Spirit and Opportunity got there. Spirit and Opportunity were sent at roughly the same time, and they're very similar. So one artist's impression, this is an animation of how they got there. So let's say it's Opportunity. You can see that as they come into the Martian atmosphere, they use the atmosphere to brake, and then when they're slow enough, they open a parachute to brake a little bit more. It's still supersonic at this point. The parachute is trying to slow down to the point where you can eventually send down the rover. The rover is inside that little pyramid. How do you get it onto the ground? Well, you either have some very sophisticated rocketry, or because this wasn't a particularly heavy one, that's what they did. Airbags. Instead of trying to soft land, they simply slowed down and then let it go. And of course, it then bounces for a while. So you have to make sure your rover is very securely packaged inside the airbags, because it's clearly going to bounce and bounce and bounce, and they counted, because there's an accelerometer on board, like you have in your phones. They found that it actually bounced 28 times before it finally came to rest. But that was considered at the time the cheapest way to get something on the surface. Rather than try and soft land, just blow up some airbags and let it bounce. The airbags were then deflated, and then the rover unpacks itself. It's self-righting, you notice, so it doesn't matter which way up it started, it will end up the right way up. So it unfolds, and then the rover itself, sitting in the middle of the pyramid, as it were, unfolds its solar panels. The first rovers on Mars were solar powered, so it was absolutely imperative to be able to catch the sun to charge up the batteries, which of course solar energy doesn't work at night, and therefore you have to charge your batteries during the day in order to keep warm during the long cold night. So the solar panels were unfurled, then came up a mast, and then what looks like a table tennis bat in the background. That's an antenna for talking back to Earth. So cameras on the top of the mast had a little bit of a look around, make sure it is the right way up, and then it said to Mission Control, yep, it looks like I've landed, what do you want me to do now? And then Mission Control sent the command, okay, go walkabouts, or at least go runabouts. So it then unpacked itself, unpacked its wheels, there they go. It did another check to make sure it knew where it was going, a little look around. Stereo cameras on top of the mast allowed it to figure out where it's heading, and then it started its journey. There's a rock in front of it, so it had to stop and then avoid the rock. The wheels turn and it adjusts itself. Bearing in mind, some of this was driven from Mission Control, but in some sense, the rovers had to be autonomous. They had to be able to figure things out for themselves. These rovers, Spirit and Opportunity, were designed to last about 3 months on the surface. NASA are always conservative, so when they say it should last 3 months, that pretty much means it's guaranteed to last 3 months, and we hope it lasts longer. But the problem is these solar panels get covered in dust, and the solar panels are absolutely critical to make sure that you can power your batteries and hence the equipment, and also keep warm during the night. That's what a selfie looks like from the camera looking down onto the Opportunity rover. To start with, the solar panels look reasonably clean, but after a few months on the surface, you can hardly see the solar panels because they're so covered in dust, which of course is the same shade of red as the dusty background, so you can hardly make out the rover at all. And when the solar panels start to get covered, then perhaps you're coming to the end of the life of your mission. Every once in a while, a little whirlwind comes along and blows the dust off the solar panels and extends the life of the rover. Opportunity was designed to last 3 months. It actually lasted on the surface of Mars 14 years and continued to operate for that length of time. A Martian day is very similar to an Earth day. The tilt of Mars and the tilt of Earth are about the same, so the seasons are very similar. You have summers and winters, depending on whether you're tilted towards the sun or away from the sun. The rotation periods are very similar, and the rovers have to stay warm during the night. They have to charge their batteries to stay warm. If they freeze, they'll never wake up again because of the nature of the electronics on board. Daytime temperatures can be above freezing, but nighttime temperatures can plummet to minus 100 Celsius or lower. And the reason Opportunity eventually came to an end was not that its wheels broke or anything. else broke, but it went through a Martian winter and it needed to charge its batteries during the day, but they had a global sandstorm, a global dust storm, which blocked the sun. And because you block the sun, you can't charge your batteries. So although it landed in 2004, come 2018, 14 years later, it finally succumbed to the cold. It couldn't charge its batteries because the sun was blocked during the day. The last transmission from Opportunity was battery low, getting dark, and that's the last we heard from Opportunity. The following missions, NASA decided we're not going to send solar panels up on rovers. We're going to use a different system. We're going to use a radioisotope thermoelectric generator, a very posh way of saying you've got onboard power that doesn't need solar panels. Perseverance, the most recent rover that I mentioned earlier, launched or landed in 2020. It arrived on Mars in a similar way to Opportunity, aero braking through the atmosphere and then parachutes. But Perseverance, just like Curiosity a few years earlier, is a lot heavier than Opportunity and Spirit. It weighs something like a ton. So yes, you can still break through the atmosphere as you come in, but you need to have a different way of actually getting onto the ground. Airbags won't work if you've got a rover weighing more than a ton. That was Perseverance inside its shell. Notice the shell is trying to steer itself. It's trying to decide where it's going to land. Again, a supersonic parachute is going to slow it down. The heat shield will then detach, allowing Perseverance to drop. They then have some retro rockets, and again, downward pointing cameras, trying to figure out where do we want to land. That had already been predetermined, so the system looked downwards, tried to work out where it was. Do I need to go left? Do I need to go right? And when it got close to where it wanted to land, they did not want to bring these retros close to the surface because that would kick up so much dust it would interfere with its operation. So they hovered and winched the rover down onto the surface, then cut the cables, and the so-called sky crane flew off and crashed some distance away, leaving Perseverance on the surface of Mars. No solar panels, you notice. The radioisotope thermoelectric generator is that thing on the back which generates all the power it needs day and night. No longer sensitive to the sun. This animated pullback here reminds you that although there might be a few rovers on Mars, they've got an awful lot of planet to explore. So there's a selfie, if you like, of Perseverance, otherwise known as Percy. It took along with it a little helicopter. That's why Percy continues to look over the side like an anxious parent looking after a toddler, making sure that little Ingenuity is still there. So Perseverance is sometimes called Percy, and Ingenuity, the helicopter, is sometimes called Ginny. How do you take a selfie? Well, there are cameras on board that mast, but there's also cameras on board the robot arm that does the drilling and the probing, and that's what's effectively taking the selfie. You can see how a selfie is taken. It's not like a mobile phone where you just hold it up, take a click, and you're done. With these rovers, you have to take a montage of lots of selfies and then stitch them all together in the final result. And that's done by this robot arm moving backwards and forwards. You can see the lens stays in the same place, even though the robot arm moves at various angles to get the entire selfie. And that results in an image like that. So where did that helicopter come from? It must have come down with Perseverance. It actually came down on Perseverance's belly. A panel was ejected, and then the Ingenuity helicopter came down from the bottom of Percy, which then rolled away to allow Ingenuity to fly. Why do you want a helicopter on Mars? Well, A, because you can. It has an atmosphere, unlike the Moon and various other bodies, so you can fly a helicopter. But also it was thought that maybe this is a good way of exploring in the future. A rover can only go at a certain speed. Maybe a helicopter would be good for scouting longer distances over rough terrain and telling the rover where to go. So there's Ingenuity. So this is a video taken by Percy of Ingenuity flying. The rotor blades are now spinning up. We have a little bit of wind noise in the background, but as it flies, perhaps you can just hear a hum. That hum is the rotor blades of Ingenuity. You're listening to a helicopter on another planet. Again, an amazing piece of technology. So Ingenuity didn't do much other than take a few dozen flights and a little bit of photography, but it proved the concept that you can fly helicopters or drones on other planets. And that led to the idea that if it works on Mars, maybe we can actually build helicopters to explore other bodies. For instance, Titan, one of the moons of Saturn, has got a thick atmosphere, so there are plans to build helicopters to go fly through the atmosphere of Titan. Not for a few years yet, but it's on the drawing board. Whenever NASA has any of these missions, whether they be landers or rovers or any missions to any of the planets, it has a wonderful public relations team. And one of the things they did for Perseverance in 2020 was to say, anybody you like can come along. We'll give boarding passes to anybody who wants them. So I applied, and NASA gave me a boarding pass. This boarding pass is actually etched onto a chip, which is on this particular bracket, which is on the back end of Perseverance. So my name is on Mars. As we speak, my name is trundling across Mars. Okay, I'm not the only one. There are thousands, tens of thousands, hundreds of thousands of people have their name etched onto a tiny 1mm chip or something like that. But it's nice to be a part of it, and that's why NASA did it. It cost them almost nothing, but the public can feel part of the mission because you know you're there with Percy. So if you want your name to go to Jupiter or Saturn or the outer solar system, contact NASA. Their webpage has lots of these lists. Do you want your name to go to X, Y, Z, wherever? You can sign up. It's free. It's just part of a public relations exercise. So why do we explore Mars? Why do we send rovers at all? Well, to study its geology, to study its climate. We want to know what Mars is all about. One of the big questions, which we've asked right from the start, remember War of the Worlds? Are there Martians? Is there any life on Mars? It doesn't look like there's any life now, but because we have evidence that water has flowed on the surface of Mars, and we think water is below the surface of Mars, it seems reasonable that life might have evolved. It's also possible life is still there, but not on the surface. The atmosphere is too thin, too much radiation, but maybe if life did start on Mars millions of years ago, maybe it's still there under the surface. It's worth having a look. And also another reason for sending rovers to Mars is to prepare for one day we might end up sending astronauts to Mars. If we want to have a colony on Mars, we need to send out these probes as ambassadors to find out what it's like out there, to figure out, can we land somewhere where there's water? Can we land somewhere where we can actually build ourselves a habitat and protect ourselves from radiation? To try and understand what Mars is made of, it's not just a question of sending scientific equipment up there on a rover. It would be nice to bring samples back and test them in our own laboratories on Earth, which generally are more sophisticated than whatever we can put into a rover. So Perseverance is taking samples and putting them in little ampules. It's collecting rock samples. It's also taking samples of the atmosphere, basically just opening them up, allowing the atmosphere in, and then sealing them back up again. And so it's got dozens of these samples as it goes to different parts of Mars. The real question is, well, that's great, but how do we get those samples back to Earth? When NASA set up Perseverance, they wanted to take samples, and they hadn't quite worked out how to get the samples back again. But that was a, we'll deal with that later sort of scenario. NASA and ESA, the European Space Agency, have thought about one way of doing it, and this is one possibility. Perseverance gets on with its job. Meantime, you send another lander, not a rover, but a lander. The lander comes down, and Perseverance goes to meet it, carrying all the samples that it's collected over the past years. It transfers all of its samples from Perseverance into the new lander that's just arrived. A few dozen of them, as you can see there. Once it's complete, the system is closed up. How do you get them back to Earth? Well, one possibility is you have a rocket inside the lander, and that rocket then blasts its way back into orbit. Perseverance says goodbye to the samples, and the samples are sent back into Martian orbit and then eventually back to Earth. So that is one idea for a Mars sample return. Unfortunately, NASA and ESA, who planned this in the first place, have now said, well, actually, that's a great idea, but it's a bit expensive. And they're now trying to figure out, is there a cheaper way of doing it? The samples are there. Perseverance is taking the samples. How do we get those samples back to Earth? They are trying to find the cheapest way of doing it. That might happen, as it indicated in that little animation, but if they can find a cheaper way, it'll happen even faster. What's on the horizon? Well, more rovers are being built. And it's nice to be able to say the next one will be an ESA rover, a European rover, being built in the UK. Yeah, fantastic. The UK is going to Mars. So this is a rover called ExoMars. The rover itself is called the Rosalind Franklin. It's not a particularly big rover, but it differs from the other rovers that have been and are currently exploring Mars because of this black box that's sitting on the front. What this is going to do is to go to various parts of Mars and drill down to see if there's water underneath the surface. Simply looking at the top surface of Mars seems to indicate no life, no water. But maybe if you go 1 or 2 meters down, we will find signs of water existing, in which case we'll then have a better chance of finding life on Mars. So this is Airbus UK. They are putting together the rover. I'm not sure if anybody told them. There's a wheel missing in the bottom there. They seem to have replaced it with a shopping bag. I don't think that's a very professional way of working, but I'm sure they realize there's a wheel missing. They are going to sort it out. So this is being done as we speak. They are putting this together with the intention of launching it before too long. A few years yet, but something like 2028, a UK-built rover, hopefully, will be going to Mars. So if you're interested in what I've been saying for the last 20 minutes or so, you can go to the web pages of NASA, the web pages of the European Space Agency. China have also put a rover on Mars. If you're interested in that, go to that web page and you can find far more about how and why we are exploring Mars with robots. Thank you very much for listening.